Hey everybody, this is Thursday's class for my 40S Pre-Cal students. And I started the class by pointing out that I had a little bit of an error in my notes yesterday. I thought that the final answer for this was example 3, the one about sound intensity and how many times louder is a goal at the MTS center when the Jets score than the recommended maximum before we put on ear protection. And I thought that the final answer was 2.5. I wasn't finished yet. The final answer is 10 to the power of 2.5, which ends up being 316 times louder. So you might want to go back to your notes and fix that. That's my mistake. I'm getting old. I make more mistakes than I used to. So fix that, and then meet me here. We are on this problem here. We are talking about E. Now, your homework last night involved, you were supposed to watch a video about E. E is a wonderful, wonderful thing. E is, of course, a number like pi. It's irrational, it never ends, it never repeats. But as you learned in the video, pi is defined geometrically. Pi is the result of taking a circle's circumference divided by diameter. So anyway, sorry. So pi is the result of taking circumference divided by diameter. In the case of E, where does E come from? Well, E is kind of harder to define because it's not geometric. It's completely numeric. And it is the natural logarithm base. So E, this number of 2.7, if you want to sketch the graph of y is equal to e to the x, well, even E behaves like every other number in the universe. When you take it, except for 0, when you take it to the power of 0, it becomes 1. So for this graph, I'm going to flip this over now so I can draw. We still good? Everybody can still see? So when I'm graphing this thing, that's going to be a 1, right? And when I graph what happens when y is equal to e to the 1, well, I get y is equal to e. And e is about, again, it's about 2.78, so I don't know what's that about here. And of course, when e is negative 1, or when x is negative 1, I get y is equal to e to the negative 1, which is, I don't know, point something. And of course, those decimals get smaller and smaller, but they'll never be 0, right? No matter how many times I times the number 2.781 blah, blah, blah by itself over and over, if I times that number to itself over and over, or if I divide it by itself over and over, right? When I have a negative exponent, that's like I'm dividing it over and over again. No matter how many times I divide this number by itself, I'll never get all the way to 0. So 0 is an asymptote. So it's going to make this curve. And you're probably looking at it going, yeah, that's just a normal exponential curve. And it is. Just so happens that the base is an irrational number, a very special irrational number, E. And they tried to tell you in the video, you don't have to mess up your diagram with this if you don't want to, because this is actually beyond grade 12. This is something you have to learn in university math, is that E is special for 2 reasons. I don't remember if they said both of the reasons. I know they talk about one of them. E is special because if I take, say, when x is 0, right there, I said, hey, come on, hey, there we go. When x is 0, say right there, if I take the area to the left and I calculate it, that area would actually equal 1, because that's what e to the 0 is. If I took the area up to here, that area would equal e, because e to the 1 is equal to e. And then, and you'll notice that the area is going to get way bigger. If I take this area all the way to infinity, this is quite the pen I'm using with it. It's a multicolored rainbow pen. If I take the area for the multicolored rainbow section, that would be e squared, because e to the 2 is equal to e squared. And that is the only function that behaves that way. I think that's super, super cool. And I can't seem to get my eraser to work. There we go. There. Okay, the other thing, and this is the one that I think the video maybe didn't mention, is if I were to take a tangent line, some of you who have done physics know what a tangent line is. It's a line that touches a curve at exactly one spot. If you wanted to find the slope of a line. Of course, what's slope again? Remember slope? Slope is rise over run. Well, how do you find the slope on a curve? Well, you find the slope on a curve by just taking a tangent to the curve. You just make a line that exactly touches the curve at one spot. So if it touched it there, you know what the slope of this line is? You can kind of see it. Actually, I almost drew it perfect. The slope of this line is 1 because e to the 0 is 1. You know what the slope of the line is here? The slope of the line here is e because e to the 1 is e. Whoa, that's trippy. That's the way e behaves. And now it's not going to let me undo stuff. I'm having some problems here. Come on. I think my tablet's kind of glitchy. I wonder if it's overheating. You're my third class today. I'm going to turn it off for a while after this. Okay, and there we go. There we go. Let's just leave it. Okay, so there's e. Now, the inverse of e is the natural log. And that means natural log is the same thing as saying log to the base e of x. So that's kind of the important part. You should write that part down. All the other stuff, don't worry about. Write that down. Okay? And ln, natural log, has all the same properties as the base 10 log, which means that those log laws, they matter. We'll do some log laws in a sec. But if I wanted the graph of the natural log of x, well, it's the inverse. Do you remember how to make an inverse? You make an inverse by turning y equals x into a mirror and reflecting it. So in other words, the y values become x values and the x values become y values. So this dot here at 0, 1 becomes 1, 0. Let's do it in a different color. Let's use blue. Right, so there we go. So that one's going to be blue. And this point here, which was 1 over e up, is going to be e over and 1 up. And this point here that was 1 to the left and whatever that distance is down is going to be whatever that distance is down and that many to the left. So it's going to be like, let's see, what would that be? About maybe there. Is that good? Something like that. Anyway, the curve is going to look like this. And just like the argument of a log can't be 0, you can't take, whoops, oh my word, what happened? You can't take the log of 0, it's undefinable. The natural log of 0 is also undefinable. So that means x on this graph can't be 0, which means that the y-axis is an asymptote. I'm not going to put any graphing on the next test. We kind of just only talked about it a little. We skipped the assignments and stuff because we've done so much graphing in this course already. I kind of want to focus on the algebra stuff. Okay. Any questions about this page though? Let's start doing some calculations with e and natural log. Evaluate the following expressions. Okay, this is just a button punch. The ln of 5/3. Can you find ln on your calculator and punch buttons? If you do, try it right now. You should get 0.5108 and change. Now, what do I do with B? Let me know if you punch buttons and you don't get the right answer for A. I'll keep my eye. I've got the chat on the other screen here so I can see what's going on. Okay, now for B. Ln of e to the 3. Well, hey, think about this. The log laws are true for natural logs just as they are for logs to the base of 10 or 2 or any other number. So this exponent can become a coefficient. And ln e is 1 for the same reason that log of 10 is 1, because the base here is e and the base here is 10. So remember why this is 1, right? Because this equation is basically saying the same thing as saying 10 to the power of 1 is 10. This equation is saying e to the 1 is e. So this is like saying 3 times 1, which is 3. Any questions on that? That's me using my log laws with my new natural log. Let me make this a bit bigger. Is that helpful? Okay, and moving on. All right, what do we do with that? Well, I'm going to change this to a logarithm. Right now, it's an exponential equation. I'm going to change it to a logarithm. I'm going to change it to the log to the base of 10, which I don't have to write, remember the word log means base of 10, is equal to the exponent, or sorry, of the argument is the answer, is equal to the exponent, which is log of 5. Okay. All right? And then from there, I can anti-log both sides of the equation. So x is equal to 5. Okay, so make sure you check that one out. Now this one, I'm going to approach this one the same way. I'm going to say, okay, I'm going to change that to an exponential equation, which means that, change it to a log equation, which means that the natural log, because e is the base, of my answer is equal to my exponent. Which means that x I'm having some problems with my pen. So 7. Okay? Now there is actually another way I could have solved this. I could have taken the log of both sides of the equation. So alternate strategy is I could have said log of 10 to the log of 5 is equal to the log of x. And then remember that in logarithms exponents become coefficients, and remember that the log of 10 is 1. So then log of 5 equals log of x, anti-log both sides, and I get the same answer. So I can do that here too. Alternate strategy, I take the natural log of both sides of the equation. Why did I take the natural log instead of regular old log log? Because I noticed I had an e in the question. And then that's going to be the natural log of 7 times the natural log of e is equal to the natural log of x. I know that this thing here is 1, so the natural log of 7 is equal to the natural log of x, so 7 equals x. There you go. Two kind of strategies for the same thing. All right. Any questions so far? More logs. Log, 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 log. Solve the following equations. Okay, so let's solve this thing. E to the power of 2t minus 1 is equal to 5. I am going to change that from an exponential equation to a logarithmic equation. So, because the base is e, I'm going to use natural log to the base e. Again, just like I don't have to write log to the base of 10, I don't have to write natural log to the base of e. E is the only possible base you can have when you say natural log. So the natural log and the answer is the argument, and the exponent becomes the answer. There you go. And then from there, I'm going to have to do some algebra. I'll add 1 to both sides of the equation. And then I'll divide both sides of the equation by 2. And then I'll give you a second. Oh, and then I'll write things down wrong. I'll give you a second to punch buttons and see if you get the same answer as me. Okay, and again, because there was people having trouble getting the right answer through calculator, everybody has to find their natural log button. It's usually fairly close. So your log log button usually says ln. You probably thought it said capital IN at some point. I know when I was younger I thought that meant in. Why is there an in button? But that's a lowercase l, so that means natural log. And I'll keep my eye on the chat here. Is there anybody who punches buttons and doesn't get that answer? Okay, nobody's saying anything, so we must be good. All right. Next, I am going to take the natural log of both sides of this equation. Natural log of e to the x is equal to the natural log of 2 to the x plus 1. What do I know about logarithmic equations? I know that exponents can become coefficients. So x times the ln of e is equal to x plus 1 times the ln of 2. Trippy. Now I am going to have to expand that bracket because my job is to get the x's together. I can't solve for x unless I can collect them. So if that makes sense, I'm going to say that this is, now I usually don't write it this way. Usually I write it ln e times x, but it doesn't really matter what order you times two numbers. So I'll just leave it like that. So x, and there's my pen dying again. Anybody know what's going on here? Anybody have a tablet and they're used to it? Is there like a battery in this thing that I've killed somehow? I'm talking about this pen. Or is it just, again, is this just me, this thing getting so hot maybe after 3 classes that I'm just, of course I didn't have that problem yesterday and I did 3 classes. There we go. Interesting. Okay, whoops. There. Okay, anyway, so this is x ln e is equal to x ln 2 plus ln 2, right? I just distributed that into the bracket like so. Now I'm going to put these two things on the same side of the equation as each other. Then I'm going to factor out an x. And then I'm going to divide both sides of the equation. And then I'm going to cancel those. And then I'm going to cry that you fell for that. You can't cancel that way. Don't do that. There's probably people who have to erase their book now. I'm sorry. That was a mean trick. I'm sorry. But you know what? I still have guys in my intro calc class who think you can cancel like that. It's driving me insane. Stop canceling like that. You can't cancel like that. You can't cancel terms. You can only cancel factors. That has to be, I think if you make that mistake enough times, it eventually has to be forcibly tattooed onto your arm. Okay, anyway, at this point I got to punch buttons. So I'm grabbing a calculator and I'm actually typing in the natural log of 2 divided by, and I'm using a bracket for the bottom because remember, BEDMAS won't know to do the subtract before the divide unless I use a bracket. So I open a bracket and then, now I actually don't really need to punch in ln of e because you know what? I know what ln of e is. How many e's do you have to times by themselves to get to e? 1. So I'm actually just typing in 1 minus the natural log of 2. And I close the bracket and head equals, and let me know if you and your little calculator, I'm going to just round it to 3 places. Oops. Let me know if you don't get that number. And if you don't, I'll bet the first mistake is people forgetting to do brackets. After that, make sure you're hitting the right button, ln. So I'll give you a sec. Punch buttons, make sure that works for you, okay? And then we'll do the last 2 on this page. And then we're going to do one more word problem. Then you can have some work done. I might even end the meeting early and let this thing cool off because it's, I think the problem, and look at that, this crosshair just popped up for no reason. I didn't touch anything. Oh yes I did, I guess I moved this, so it's decided I want to think of it as a picture. So make that go away, it's in the way. I got a lot to learn about this tablet. Okay, anyway. Any questions? I'm looking at the chat. Nobody's saying that they're stuck. I'm going to move on. Ooh, check this one out. So I'm going to take the log of both sides of this equation. So I have the natural log of e to the natural log of 2y minus 1 equals the natural log of 5. In logarithms, exponents can become coefficients. And I know what this is. This is times 1. Right? The natural log of e is like saying how many e's do you have to times by themselves to get to e. It's like saying log to the base 2 of 2. How many 2's you got to times by itself to get to 2? The answer, of course, is 1. That should totally make sense to you. Right? Log of 10 is 1. How many 10's you got to times together to get to 10? 1. Right? Another way to think about it is, of course, this is the equation. 2 to the power of 2 is 1. And, no. 2 to the power of 1 is 2, and this is the equation. This is the equation. This is my pencil dying. This is the equation. 10 to the power of 1 is 10. Okay? All right, these are kind of in the way now. Do you mind if this was just scrap thinking. I'll just get rid of that. Okay, finishing this guy off. This is a ln. I'll just write this again without the times 1 because the times 1 doesn't mean anything. And then what do I do here? Oh yeah, remember that I can anti-log both sides of the equation. Well, I can anti-natural log both sides of the equation as well. So this now becomes the equation 2y minus 1 is equal to 5. So 2y is equal to 6. So y is equal to 3. And you probably should check your answer. So let's do a check. And I'm kind of out of room. Can I move down a little bit? I'll do a check. So does e to the power of the natural log of 6 minus 1, which is 5, equal 5? And as you can kind of see, yeah, that has to be true. And if you don't get why it's true, by all means, you can punch buttons. Now, we haven't actually shown you that yet. How do you get e on your calculator? Well, on some calculators, it's just right there. If you take a look at the natural log button, which is the button that usually says ln, sometimes the shift of that button is, like the one I'm looking at, it's e to the x. So I would actually punch this in as just going, okay, shift natural log, and then I'm going to open a bracket and hit natural log of 5, and it's going to spit out 5. Ta-da, it worked. Now some of you, who was it that had the old TI 30XA? Getting E on these calculators is a pain. You actually have to go, how do you do it? Okay, I've forgotten how to do it. You have a natural log button. Oh no, it's still e to the x. So you would go, you would put, I guess you'd put the natural log of 5 in first. No, you can't. You put 5 on the screen, hit natural log, and then hit shift e to the x. Yep. So if you have, who was it? I shouldn't say names, I'm recording. But if you have one of these old-fashioned calculators and you were asking me about it yesterday, if I was trying to do this calculation, I would punch the following buttons. If you don't have an old calculator, you don't have to write this down. Even if you do, you don't have to write this down. You can just watch and just kind of make sense. Punch buttons with me. Here's the order I'd punch buttons to do this. I would put 5 on my screen first. I'd hit natural log. That gives me this number. Then I hit my second function, my shift button, and my ln button, which is where e to the x is. And then I don't even have to hit equals. It should spit out 5. Let me just make sure I did that right. 5, natural log, second function, inverse of natural log. Yes, that should work. So I'll give you a sec to give that a try. And it should work, I hope. I hope. Okay, any questions on punching buttons, getting E? And again, if you want to just get E as a number, just punch in second function log of 1, and it'll spit out E. 2.71828, right? Because remember, E to the 1 is in fact E. Anything to the power of 1 is itself, right? So if you just use your calculator, if you have a button that says, again, ln e to the x, get, or I wrote that badly, e to the x. If you activate this function when your screen says 1, so if you do this to the number 1, it should spit out e, which is 2.718 blah, 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 to infinity. Okay? All right. Now, as you, this is in my way, I'm going to erase all this. As you learned in the video yesterday, oh wait, we got one more algebra. I'm sorry, we're not ready for the word problem yet. Oh, we've got an ugly one. This is, okay, this is a tough one. Okay, one more piece of algebra, and then we'll move on to the word problem. Okay, how do I solve that? Well, I'd be kind of stuck if I didn't realize something that I just said a second ago, that the natural log of e is 1, because this is like saying e to the power of 1 is e. So I can turn this 1 into ln e. Dun, 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 dun. Now I can use my log laws. Remember that in log laws there is really no difference between an addition and a multiply. And then I'm going to go anti-log both sides of the equation. And then I'm going to have to, now this is like saying, this to me is no different than the equation x plus 1 equals, I don't know, 3x, right? I'm going to have to combine these two x's together at some point, right? So I'm going to minus e times x from both sides of the equation, then I'm going to minus 1 from both sides of the equation so that I've isolated x. I'm going to factor x out, and then I'm going to divide both sides, because I actually don't know what x minus e is. And then I'm going to divide both sides of the equation by 1 minus e. So that's how I would solve a question like this. All right, punch that through your calculator, and you should get, just write it down, you can try it later. You should actually end up getting a positive, because the top is negative, the bottom's negative, so you get a positive 0.5189. And if you really wanted to get fancy, if you really wanted to get fancy with your calculator, you could use that in this equation using your answer button, and it should balance. Both sides of the equation should be the same number. I'm not going to go through that. You can try that on your own if you like. I'm quite sure it's the right answer. All right, we got one more to do, and then I'm going to have to, I think again, I'm going to have to shut things down. I can always leave the meeting open and switch maybe to my document cam and give this thing a rest. Okay, the value of e is often used to solve exponential application problems. You guys saw in the video that I assigned for homework that you can use e in financial equations, right? It is basically continuous compound interest happens at a rate of e. The value of e is often used to solve things like exponential growth problems. There are 500 mice found in a field on June the 1st. On June 20th, 800 mice are counted. If the population of mice continues to increase at the same rate, determine how many mice there will be on June 28th. So what we know is we have a formula. The amount of final value is the initial value times e to the power of rate times time. And it says, notice, if r is greater than 0, then the function increases exponentially. If r is less than 0, it decreases exponentially. And right now, we actually have no idea what r is. So that's kind of our goal, is to figure out r. So to figure out r, we know that the amount of mice is 800 when I started with 500, but I have no idea what rate that happened at. Oh, but I do know that it took 20 days. So t is 20. So that's the equation I have to solve to figure out r. So maybe I'll write in words. First, I have to find r in order to solve the question. This is a two-part question. All right, I'm going to divide both sides of the equation by 500, which makes that 8/5. Might as well make r times 20, 20r. And then I'm going to take the natural log of both sides of the equation. The natural log of 8/5 is, I don't know, we'll figure it out. And the natural log of this side changes the exponent to a coefficient times the natural log of e. And we've already talked about this. The natural log of e is 1. So my natural log of 8/5 is equal to 20 times r times 1. I don't have to write times 1. And then to solve for r, I'm just going to find the natural log of 8/5 divided by 20. And that will give me the answer. Punch buttons, you should get a rate of 0.0235. Now, when I use that rate, I'm going to leave it like this, but if, for a final answer, I can say, of course, that that is 2.35%. But the answer, of course, is now I want to find out how many mice there'll be on June 28th. So I'm going to go back to the formula. Amount is equal to E, but now I know that R is 0.0235, and time, since I started counting on June 1st, that's 28 days later. Ooh, 28 days later. That's a favorite movie of mine. Okay, so punch that through your calculator. Now here's where you have to use that e to the x button. This is a button on your calculator, right? So I'm going to type this in as, now I'm going to use this crappy old calculator here. I'm going to put 0.0235 times 28, hit an equals, get an answer, and then second function e to the x. And that didn't work. I don't know why it didn't. Hold on, let me try that again. 0.0235 times 28 equals second function exponent. equals. I don't know why that didn't work. Oh, whoops. Oh, can I have a mistake on that? What did I forget? Guess what I forgot, guys? What did I forget? Look at the formula. Anybody notice and say it in the chat? No. Have you all fallen asleep? Wake up. What did I forget? Look at the formula. I forgot the P number. How many mice did we start with? Sorry about that. So let's try that again. I'm going to take 0.0235, times it by 28, take e to that power, and then times it by 500. And that gives me, yeah, that's the answer I got last time. 965 mice. Those of you with fancier calculators, you can actually just type it in exactly the way it says. You can type the buttons, 500. That means type a 5 and a 00. Please don't look for a 500 button. You won't find one. Times. I said times. Then your second function, or shift, whatever it is, and then that button, which of course activates this. And then open a bracket if it didn't open one for you. If it opened one for you, you don't have to do this step. And then 0.0235, and again, just punch the buttons, don't look for that button, and then times 28, close brackets, and hit equals. There. Button punch theater. Try that and see if you get this answer. Okay, and that's it. That's all of the examples in the book. Time to do word problem practice. You can now, yesterday I said if you want to start on the homework you can, but avoid the questions that have E in them because we haven't talked about E yet. But now that we've done the E lesson, they're all fair game. Okay, I think what I'm going to do is maybe, I might even pop out of this meeting. Okay, don't go anywhere yet. I'm going to actually, I haven't printed my attendance out yet. I'll do attendance right now. Okay, so attendance I do by going to the meeting. Okay, first I'll stop the video. So anybody watching at home, video is now over. Bye-bye.